All right, here are solutions for quiz 7 for Math 213. Name the additional parts that you would have to get congruent in order, there should probably be a comma here maybe, in order to show that triangles are congruent by the theorem specified. List all possible answers to each problem. Okay, so for this first one, A, what I'm trying to show is that this triangle ABC is congruent to this triangle DEF. Note the order that those guys were specified by angle, angle, side. Well, I'm given two angles, so I need one side, but that side can't be in between the two angles. So either I need to be told that this side is congruent to this side, so that BC is congruent to EF, or I need to be told that side AB is congruent to side ED. If I am given either of those pieces of information, either that this is the same length as this, or that this is the same length as this, then I can say that these two triangles are congruent by this specified theorem, angle, angle, side, or angle, angle, side. All right, part B, Gh I congruent to JKL by hypotenuse leg. Okay, so technically, hypotenuse leg says that you have to have a right triangle, which I do here, and a pair of congruent legs and a pair of congruent hypotenuses. I don't know if that's how you say that. So technically, I guess what I should say is that length Gh is congruent to length Lj. And then I'm going to say optional to include that length IH is congruent to length LK. Why am I saying that's optional? Well, that would be the other leg here. And if you were given the two legs are congruent, then really you have that the hypotenuses are congruent because they have right triangles. A squared plus B squared has to be equal to C squared. So I don't know if it would quite fit this hypotenuse leg, but it would kind of imply hypotenuse leg. So whatever. If you put that in, great. If you don't, that's okay. I don't really care. What about C? C says MNO, this guy here, is congruent to PRO by side, angle, side. Okay, so I need two sides, and those sides have to have this angle included in between them. So really what I need is that NO and OR are congruent, and that MO and PO are congruent. So here it's not an or, but an and. I need NO to be congruent to OR. The order that you write those vertices is not important. And I need MO to be congruent to PO, or OP. I don't know what order you wrote those in. Fine. That's why I need it for C in order to get side, angle, side, side, angle, side. What about D? It says STU is congruent to VWX by side, side, side. Well, this one's relatively straightforward. I need all three sides. I already have one side, so I need two more sides. I need TU to be congruent to XW, and I need WV to be congruent to SU. Okay, so I need TU to be congruent to WX, or XW. And this is another and in here. I need XV to be congruent to US. And the last one, E. I want angle, side, angle. I have one side, so I need two angles. What I need is the two angles that kind of go about this side. So this angle and this angle. I need angle T, let's put the little angle mark, to be congruent to angle E. And then I'm going to say optional to include angle O. Now, I'm not going to say optional. I'm going to say don't include angle O being congruent to angle O, because that's already implied by this picture right here. Anytime that I have lines crossing, their opposite angles are congruent. So you already have that O is congruent to O, even if it wasn't marked in the picture. So really, this is the only one that you need here. That'll be the answer to this question if you want them to be angle, side angle. All right, and that's the end of number 1, I guess. Number 2, sketch non-congruent triangles where angles A and D are congruent, side lengths AB and DE are congruent, and side lengths BC and EF are congruent. This is getting at the fact that if you have two sides and one angle, and that angle is not between the two sides, this doesn't guarantee or give congruency. And to show that, well, you want to draw two triangles where that's the case. So let's start out with an angle here. There's an angle. And there's a side. And so I have that this angle here is congruent to this angle here. Not drawn particularly well, but hopefully it's close enough. I can make that look a little closer maybe. Whatever. And then I have this side length here. So this side length has to be the same as, those look about the same. And then the third side lengths have to be the same. And you might think that that locks you into a given triangle, but in fact it doesn't. If I draw this side length, I can draw a side length over here from this point to this line extended. That's the exact same length as this guy. If I have it kind of looking like this maybe. So note, I mean, it's a little bit hard to draw in my picture that this length is roughly the same as this length, and this length is the same as this length, and these angles are the same, but these triangles are not even close to congruent. It's definitely not congruent. So drawing something like this would be what you're looking for. In the triangle below, not drawn to scale, line segments AD and CD are perpendicular. Here's AD, here's CD. Those guys are perpendicular. Line segments AC and EB are perpendicular. There's AC, there's EB. They're perpendicular. And triangle ABC is isosceles. ABC. Let's see, an isosceles triangle, the way we define it is it has at least two congruent angles. So I have that side is the same as that side. And that turns out to imply that these angles are congruent, and therefore these sides are congruent. Find and justify two congruent triangles. Okay, so congruent triangles, I want to use one of my theorems from before. And you can kind of just process of elimination this. Nothing's going to be congruent to this big triangle because nothing's as big as this big triangle. So you kind of have these three interior ones, and it sort of looks like these two are congruent. This one doesn't really appear to be congruent to the rest of these. It's dangerous to judge these based on appearances. So let's see if we can prove that. I think what we'll see is that A, E, B is congruent to C, E, B. That's not a B. Let's try that again. C, E, B. And how can we prove that? Well, let's see what we have here. I have this angle is congruent to this angle. And I have, this angle and this angle. And I have this angle and this angle. And I have these two sides are congruent. So one way I could say that this is true is by side, angle, angle. But note that if these two angles are the same, then these two angles must also be the same. So I guess I could have said that I have a side in between two angles. So I could have said that I have angle, side, angle. Or let's see, I have a right triangle and I have a leg in common. Do I have a leg in common? Yeah, this leg right here in common. And then the hypotenuse in triangle. So I could have used hypotenuse leg. Or I'm sure there's other ways you could have done it. You probably could argue that this is the same as this somehow. So I'll just put or dot, dot, dot. Lots of different ways you can prove this. I think angle, side, angle, or side, angle, angle are the two most obvious. But however you want to do it, make sure that the order you write these vertices are, you pair up corresponding vertices. Something like this would do the trick. List all of the triangles that are similar to ACD. Okay, I think to do that, for me anyways, it helps to label my angles. So if I call this X right here, note that this right here is also X. And so if this is X and this is 90, this right here would be 90 minus X. So triangle ACD, if I look at its angle measures, Angle A has measure x. Angle C has measure 90 minus x. And angle D has measure 90. So the question is, can I find any other triangles that have x, 90 minus x, and 90 as their angle measures? Well, here's an x, and here's a 90, and because these three angles have to sum to 180, this one down here must be 90 minus x. So what that tells me is that triangle A, B, E is similar to this guy. And do I have any others? Well, I know that ABE is congruent to CBE from the above. So therefore, if ABE is similar to ACD, CBE must also be similar to ACD. And I think that ends up being all of them. If this is 90 minus x, I'm using up x of them here, so this is 90 minus 2x, which doesn't correspond with any of these guys. So this triangle here won't be similar, or won't be guaranteed to be similar to any of these others. So I think this is all that I have here. So that's the last answer, so I guess I can end this video here.